Thank you very much for coming. This is the one session you've been waiting for all week long. What's new in VMware Edge Compute? My name is Saadat Malik. I'm the VP General Manager for the Edge Compute division at VMware. So probably the right person to tell you what's new in Edge Compute Stack, although I'm going to exaggerate, so please take everything I say with a pinch of salt, OK? So with me today is the person who's going to tell you the real truth. What actually is new in Edge Compute Stack? We have with me Anand Srinivas. Anand is the Chief Software Development for our business unit and is the person who's going to help you understand what we're actually doing. So once I'm done with telling you all the big stories, Anand is going to tell you which part of those stories is true and which part is fiction. All right, let me get started. So I think all of you this week have seen all the buzz and excitement around Edge, right? This is the thing that VMware is getting into. So VMware has been a dominant player, as all of you are witness, in the data center space, done phenomenal work, right? Virtualizing things, consolidating things, making it efficient, making it manageable. Now the customers are coming, many of you are coming and saying, hey, good job, but our data is moving. Our data is no longer in the data center, it is moving to the edge. It's moving to our factory floors, it's moving to our retail locations. What are you doing there? And VMware, kudos to us. See? I told you there's going to be a lot of fiction here, right? So kudos to us. We're turning around and telling our customers, guys, we got you. We're going to take care of you. We're going to help you manage your environments at the edge, whether it's factories, retail location, you name it. Same brilliant way that we have helped you do it in the data center environments. So for those of you who have had challenges in the data center environments, please forget all those. We're not going to have them on the edge. It's going to be a perfect journey from the very get-go. So I'm sure Anand is going to correct me when he comes on the stage. So it's going to be a lot of fun. It's going to be a lot of fun. There is an amazing amount of things that are happening at the edge. You guys are probably here because of that. You're hearing that our retailers are putting all these cameras up there in their retail locations. They're generating all this data to help them analyze whether there's theft happening in their stores, whether there are employees who are not doing their job properly, whether there's shelves which are empty, whether shelves which nobody goes to, somewhere in the back, which are stocking the highest priced items that they have in the store, right? So they're doing all of those types of things, and they want a way to manage all those applications in a proper way. You know, the big thing I'm going to tell you in a second is software-defined edge. They want us to bring a software-defined edge to them. So what is software-defined edge? So I can bore you with this definition, which is a great definition, by the way. Somebody much smarter than me put this together, so it is a good definition. But let me instead tell you a real-world example of what software-defined edge is. So we have a customer in Germany, right? They are a big car manufacturer. They make awesome cars, some of the best in the world. Their name is Audi. Heard of them? Anybody? Anybody owns an Audi? No? OK. Let's delete that portion from the video if you don't mind. I was hoping a few hands would go up. But hey, so they make Audis. They're a phenomenal manufacturer. They are state-of-the-art in terms of what they do. What Audi is doing is that they are saying that, look, we have done things a certain way for a very long time, right? Our factory floors are very hardware-centric. We have these programmable logic controllers, HMIs, IPCs, industrial PCs, sitting on our floors, which are doing all these things to manufacture these cars. So now they're saying, hey, that's all very good, but we have seen some very interesting things that you guys, when they say you guys, they're talking to all of us, the knowledge workers. We have seen you guys do some very interesting work with software. You guys seem to be able to configure things so easily. You are able to program things. You are able to change your data centers on the fly. I mean, that's what they think. I mean, I know that it's not that easy. But they basically think that software, if you do things in software as opposed to hardware, is way easier. It's way more flexible. It's way easier to upgrade things, update things. right? So they are saying that, hey, we would love to have all of that on our plant floor. Why are we still doing things in a hardware-centric way? We would like to do it in a software-centric way. That, folks, is software-defined edge. They are basically telling us that the programmable logic controllers, PLCs, that we have on the factory floor, they would like to virtualize them. They would like to take that hardware, convert it into a software, so they can easily update it, upgrade it, observe it, manage it, secure it, all those fun things. That, in a nutshell, folks, is software-defined edge. And that's what we are focused on building in my organization. We are helping our customers build a software-defined edge. So a lot of folks, right, edge is, there's so much hype around edge. People often come and say, why are you building this software-defined edge? Right, so I think you have gathered some of that already, right? So when I told you why Audi is doing this, right, they want to make everything easier. Fundamentally, what we are doing for our customers, if I were to generalize that a little bit more, every customer of ours at the edge has some business outcome they have in their mind, right? If it's a retailer, they maybe want to reduce the theft in their stores, right? Maybe they want to improve the traffic patterns in their stores. So people go to the shelves which have the most high margin stuff in there, right? So it's all about bottom line and top line. Today, when they want to do that, it's a painful process. It's not as painful as it used to be 20 years back. So I've been in this edge space for 20 years doing this stuff, from the time when we used to try to figure out how to get a router up in the mountains at minus 30 degrees. How do you make that work? To the point where we know the routers can work there. We have figured out ways to do that. We also know that you can make money putting routers up there. Now the question is, can I do all this without losing sleep? Can I do all this without getting ulcers? Right? That is the question. So what I'm building for these people, right, what my organization is building for these people who are our clients at the edge, is a platform that allows them to deploy a solution in their edge environments in a friction-free manner. That's, in a nutshell, what I'm doing. I'm giving my retailers a platform that they can use to deploy applications easily, which has certified hardware underneath it, so they don't have to think, they don't have to worry what hardware, what software. They can put that. We have partners who are providing the applications on top, all of that together in an easy way. And not just that, right? That platform also lets them manage that environment effectively, right? So that's the vision, that's the strategy and the path that we have, that we are chasing right now for our customers. Let me talk a little bit more about some of the problems that we are solving for. Fundamentally, so since the time I started doing edge, right, things have changed a lot, right? There used to be a time early on, right, when we used to have like maybe 1-2 applications that people wanted to run in their environments. I'll give you one quick example of this, right? Police cars, right? There used to be a time when the policemen started saying that, hey, we would like to maybe have something in our cars which lets us do automated license plate reading, right? So if there's a car in front of us, we would like some camera to read it automatically and then basically tell us who it is. Are they carrying a gun? We're in US, right? So especially in the South, right, we have laws, right, which allow that to happen. So do we know that the person is carrying a gun or not? So now that was the initial times, right? The game is changing now. Now the policemen are coming to us and they're saying, hey, not good enough. I have a police station where I can do a whole lot more than that. I can do criminal background checks. I can look at the video from a certain scene where I am. I can look at the cross-section. I can look at what stores are open at what time of the day. I cannot do any of this in my car. I have to call people up. If I'm in my police station, I can do all of that. They're essentially now saying that they would like us to move their entire police station application stack into the car. That car is the edge. It's a mobile edge, but it's the edge. So think about the proliferation of data that is now going to be generated, computed, and then acted upon at the edge. It's changing dramatically. It's a game changer. That's why there are estimates out there. that very soon, like in 2 to 3 years' time, 70% of the data, think about it, right? 70% of data is going to be generated and processed at the edge. Only 30% in the data centers in the cloud. It's a changing world. It's a game changer that is upon us. And that is the reason, right, that we are having to build these platforms to address this need. Edge is no longer a nice to have. This is bread and butter for our customers now. The other thing that we need to keep in mind is that these applications, right, the application that we run in the police car, for example, it can no longer be the same type of application that they have in the police station. The applications that we traditionally have run in the data centers, those applications were great, right? But they do not solve the purposes for which we need to run them at the edge. And more importantly, they do not take advantage of the distributed nature of the edge environments. So these edge applications need to take advantage of some of the things that we can do at the edge in terms of connectivity between sites, for example. If you have 5,000 stores, for example, right? 5,000 store locations, each one of them has applications running on it. Wouldn't you like for those applications to talk to each other? So let's say that there's an area where there's a very high margin product that you're selling in one of the stores, and another store that product is out of stock. Wouldn't you like for somebody to take some of these products and put it in the other store? That's the beauty of the distributed environment. So you would like to have that. You would like to also have AI playing a role in that. Some of the things that we used to do with centralized applications, those are no longer valid. We have to start looking at a distributed application environment. We, in our group, called it the edge native apps. Apps that are made for the edge environment. That's the other problem, right, that we are trying to solve for our customers. And then one of the critical things, right, that I want to make sure that I emphasize here, in my view, I know I work for a technology company, right? Most of you probably also see it that way as well. Technology is probably like 20% of this problem, the problem that we are trying to solve at the edge, making sure that, and that problem is, how do you enable business outcomes in the edge environment? Technology is probably 20% of that. 80% is people and its processes. So the processes that need to be changed are so significant that those are the ones that consume most of our time. The people changes that we need to implement are the biggest part of that. I'll give you an example, right? I'll go back to the manufacturing plant floor. On the plant floor, right, there are people who are actually making the vehicles, right? These are the guys who actually have done for decades. They know what the difference is between a good panel on a car and what is going to break on the next step in the production process. They really understand that. So our goal, obviously, from automation and all that is to take that tribal knowledge and convert that into applications and, the way we do things, right, in the knowledge worker environment. We basically take that, convert that into algorithms. If there's AI, we do machine learning and all that good stuff. But the reality is that until the people on that factory floor come on board with us, they agree that, yes, this is how we are going to make a good car panel, nothing is going to change. The resistance that we see between the OT people, who are the people on the factory floor, and the IT people who are trying to implement these changes is massive. So that resistance is another problem that we have to solve at the edge. It's no longer possible for us to just say that, hey, we have this technology, we're going to implement it for you, and walk away. That no longer works. There used to be a time when people used to force those things. It's very clear that not only the people in these OT environments want to learn and understand how things are done, but they also want to be part of the change. They do not want the change to be thrust upon them. So that's another key thing. So add to that, right, all the issues that we typically have on the edge environments in terms of latency, bandwidth, privacy, reliability, and it becomes a significant challenge that our customers have on their hands. It is no longer an easy kind of a thing where I go and I make a statement that, hey, I have built you a platform which is going to make for friction-free business outcomes on your edge. It's not an easy statement to make. It is a pretty difficult statement for us to make. So let me tell you a little bit about how we are making that happen. So what we have done is that we have started formulating what this platform needs to look like in order to solve all these challenges that I just talked about. So these 6 boxes that you see on this slide, they essentially talk to some of the key elements of our vision for this platform. The first piece is fairly obvious, the edge runtime, right? So you want to have a runtime environment that makes sense in these edge environments. It has to be right-sized. You cannot have massive runtime which takes up so much resources that there's nothing left for the applications to run, right? And keep in mind that the hardware is going to be constrained, right? You cannot have massive servers sitting on a factory floor. You cannot have massive servers sitting in a small store location, right? You will have to right-size the hardware, and to right-size the hardware, you will likely have to right-size the software on it as well. So runtime is important, and then you also will have challenges because some of these environments that we are dealing with are actually not typical IT environments. Going back to factory floor, they run Profinet in Europe, right? Profinet is a protocol that we don't deal with in IT. They run Profinet to communicate between devices. We have to deal with that as well. So the runtime has to be able to deal with that. It often has to deal with real time, because who knows, right? There might be a robot arm that is swinging on the factory floor. The camera catches it because there's a person standing in its swing and tells it to stop, but we are not able to communicate effectively from the programmable logic controller to the robot. That is a disaster that we don't want to happen. So we have all those challenges that we need to address, which essentially are fixed with this thing, right? So this basically provides the foundation, right? So if you want to go to the edge, want to deploy applications, this is going to be the foundation, a good, meaningful runtime for these environments. Second thing that you want to do now is that you have 5,000 stores. Do you think, so I just got out of a customer meeting. These guys are based in US, 800 stores. The guy was telling me, he's the head of their IT, their CIO essentially. He was telling me that at no time are all 800 stores online. Part of it is that they are kind of a mixed bag, urban, rural. Some places have connectivity, some of it is good, some it is not. There are other types of issues as well. Net, never a situation where all the 800 stores are online. Some are always off, and he was thinking maybe it's 10%, maybe it's 12%. Now, if you want to run an environment, think about what a headache it would be if you're trying to push configurations and the state information down to these 800 stores at any given time, when you know that a lot of them are going to be offline. So we are changing this model. We do not believe this model works anymore for the massive scale that we are encountering at the edge. So we are changing the model. We are flipping it upside down. And what we're doing now is that we are saying that we are going to do a pull-based mechanism for making this happen. So each store, each of the 800 stores, is going to go up into a Git type of repository, pull down its state, the state that it needs to be in, and go from there. If it is not connected at that point, it will try again. But it's not going to be on some central location to try and push something down to that. So we're changing this completely. I know that some of you are already familiar. You're thinking, oh, yeah, well, how does iPhone work? Oh, yeah. Similar. So the concept has been tried before. We're not the first one to invent it. But we are the first ones to implement it in an enterprise-grade edge environment. So this is something which is key, which is changing. End-to-end security at scale is essential. We have to make that happen. But what's at the bottom right is the really exciting part. This we will implement for you at the top and get this out to you very quickly. This thing at the bottom is the real exciting part. I'll start with the data platform. Think about 2 applications, right, running together. One is an employee database application. The other one is a theft detection application. Again, I'm going for the retail store location. Wouldn't it be nice if we could figure out that if a theft is occurring in a store, if there is the right type of employee available at that time, is on duty, to be able to go and deter it, to do something about it. On a factory floor, if an employee is not in that day based on logs from badge in and badge out, if that person's absence is causing a safety issue. Wouldn't it be great if the apps could actually talk to each other? So what we are building as part of this orchestration tool, this is again in the future, This is something that we will talk about a little bit more. It would be great if these apps can talk to each other and make sense of this data. So RabbitMQ, that's the technology that we have, event messaging, the messages correlating with each other and then making sense. And finally, taking all of this, right, and making AI make sense. Think about it, folks. AI is the big buzzword right now, right? Everybody's talking about AI. But how do you actually implement AI in these edge environments? You have all these constraints. You have a situation where most of our folks, right, who are implementing these are probably not going to be super tech savvy in these edge environments. How do you actually make this make AI work? It is, in a way, right, about lifecycle management again. So we are used to doing lifecycle management on hardware, right? Like you deploy a box, you run it for a while, you retire it, all that good stuff, right? On software too. I think what is going to happen now is that we'll start having to think about lifecycle management for AI. What models do we deploy? Where do we deploy? How do we deploy? How do we keep them updated with new learning? And then how do we retire them? And how do we come up with new models? This orchestration tool that we are building for you guys, right? The vision that we have for the product is going to allow for that AI to become reality. So taking it from the hype that we have to the reality. And think about the massive amounts of data that is going to be generated in these edge locations. Private AI that you have been hearing from us for the past few days, that is going to become the next killer app at the edge. So think private AI at the edge. That is what our platform is going to enable for you. So I'm going to stop here, and I'm going to request my co-presenter, Anand, to come in. He's going to talk about some more details. We're going to be here after the event as well to answer any questions. So thank you very much. Anand?
All right. Excellent. Thanks, Saadat. I mean, so far, everything he said is true, so there's that. Absolutely everything. So now we're going to get in, double-click, get into some details. One of the big areas that we're working on, as Saadat mentioned, is around pull-based orchestration and dealing with the edge as a fundamentally different problem than what we do in the data center. And Raghu alluded to this in his keynote day before yesterday, where we are introducing the VMware Edge Cloud Orchestrator product. And the idea is to have a single experience for all of the different edge services that we have at VMware. So this is not just edge computing, but also to orchestrate things like software-defined WAN, secure access services edge, so cloud web security, secure access, and even things like private mobile networks as well. As one single, single platform that you can log into to enable these different services depending on what you've purchased. Now, on the edge compute orchestration in particular, when we get into it, basically, actually, let me just build this slide out, right? Our vision for how orchestration should work is that a box gets sent to the edge, right, from the factory, either preloaded with software, and we'll get into the details of what exactly is preloaded, or potentially bare metal is just sent to the edge site, but securely downloads its image and things like that. But then once that happens, what we're aiming for is a zero-touch provisioning experience, where rather than, as Saadat said, pushing configuration from the data center, requiring potentially inbound connectivity into a private network, which isn't going to be very practical, we want the edge nodes themselves to call home and automatically update themselves, configure themselves, and be in a state that's ready to accept new applications, whether VMs or container-based application workloads. And so that's the first aspect of it, and that's the infrastructure layer. Then Kubernetes, right? So VM-based workloads is the first part. Then enabling Kubernetes-based workloads to be placed on this as well, having a Kubernetes local control plane. We'll get into the details of control planes being local and how we're going to do that as well. And then beyond there, to achieve the vision that Saadat talked about earlier around enabling AI, pulling AI models from the orchestration as well, and services, message, data, and all of those aspects as well. And finally, lifecycle management for all of this, keeping everything up to date, being able to change configuration on the fly, security patches, all the rest of it. So that's the overall picture. Now, the details of what this looks like is something like this. And what you're looking at over here is a picture where at the bottom is what we deploy at the edge. And so what you're looking at here is what the software looks like on the edge initially. It's ESXi, right? That's still the base. It is what we call the local cluster control plane. So this is to enable things like VDS, DRS, vSAN, all of those ESXi or all of those VMware features that differentiate us to enable it locally at the edge without needing connectivity back to a central data center, vCenter, right? So that component is going to be present. And then the other component that's going to be present is something called the edge agent. And the edge agent's job is to call home and pull configuration down and make sure that the edge is up to date and all of that. And the idea around this workflow is the box gets sent. One possibility, and we're still exploring others as well, is that somebody on site who we know is not going to be an IT expert just activates the box with a click of a link, right? And once they activate it, the box calls home and calls home to this edge cloud orchestrator, which initially is going to be a SaaS solution. That's what we're developing right now. But we will target an on-prem version as well, a private cloud version as well. And then the last component here on the top left is enabling GitOps-based processes, and therefore using Git as the source of truth and as sort of the database in some sense. So enabling customers to follow infrastructure as code and deal with updates and things like that in a Git manner, right? Using Git processes with CI/CD pipelines, canary deployments, and all this stuff, and tracking who made changes, being able to roll back changes very easily, all of that stuff that's inbuilt into Git, right? Enabling that and leveraging that for the solution. And so these are the different components. One thing that you guys may have seen, if you guys have attended some of the other sessions, is a technology called Project Keswick, and the technical showcase that they've introduced. And actually, this whole architecture, it'll seem vaguely very similar to Project Keswick, and there's a very good reason for that. Is that Project Keswick is providing the technological underpinnings of this, but while Project Keswick is a tech showcase that sort of it's based to just get an MVP out there and just get feedback. This is going to be a commercial offering that we're working on to develop over time to support multi-node clusters and all the rest of it. And so, be ready to see this soon. So what does the workflow look like? At the end of the day, a box gets shipped to the site, right? What happens on the UI of the orchestrator is that IT logs in and pre-provisions the box, says that this box with this serial number has been shipped to this particular site. On the site, the site manager or facilities or whoever is there plugs in the box, and as of right now at least, the initial proposal is, hey, they connect a laptop or a mobile app to a network port and click a link and it automatically activates it. It puts the authorization key and IP configuration. Now, one thing that we've gotten a lot of feedback on is why don't we just make this completely zero touch and completely assume DHCP and just have it call home. And that's definitely something we're looking to do as well. So we're going to have different workflows on this side, but the idea is that we don't want to make any assumptions that the person on site is logging into vSphere and trying to do some complicated configuration or anything like that, because obviously that's not going to fly. But then once that's done, everything else is automatic. The edge agent phones home, updates itself, and puts itself in a situation where it's ready to get desired state, both for VMs as well as containers. And that ongoing operations part is an option for customers, whether they just want to deal with the Git repo and just do their own. You guys can update yourselves in terms of merge requests, processes, and dealing with changing desired state that way. Or we'll also provide a UI-based approach to do that as well, depending on what kind of automation and what kind of sophistication is present. So that's kind of our vision for edge orchestration. It's probably the main thing that, one of the biggest initiatives that we have. And the idea is, management at scale, holistic edge management, and, one of the things is to treat the edge a little bit more like we treat customer premises equipment, like router or like set-top boxes and SD-WAN routers and things like that, as opposed to the way we've been looking at it with the data center approach, which is a push-based model. The next thing I want to talk about are some things that we're working on the runtime. And this is going to be particularly relevant for industrial customers. And from what Saadat talked about in terms of some of our work with Audi and Siemens as well. And the big use case in industry, in manufacturing and utilities, is virtualizing programmable logic controllers. So these are hardware-based appliances today. And again, to get to the software-defined edge vision that Saadat talked about, they want to virtualize this and get this into the software domain to get that software agility. But obviously, there are strict timing requirements for these type of applications. And so the initial use case here is looking at cycle times of around one millisecond and virtualizing this, but making sure that we always hit that scheduling deadline. The other requirement is around industrial protocols and multipath reliability. So protocols like Profinet or EtherCAT or Ethernet Industrial and things like that. And then multipath redundancy protocols like parallel redundancy protocol, where traffic is sent at layer 2 on multiple paths simultaneously. And these are critical requirements before the OT folks feel comfortable enough to enable this kind of virtualization to occur and to sort of get to that software-defined edge that we all want to get to. And so some of the additions that we're doing to enable this is we are putting Profinet support into our enhanced data path virtual switch, right? So we're adding that capability so that Profinet traffic also enjoys the same ultra low latency that other traffic can go through with the enhanced network stack. The other side of it is also adding parallel redundancy protocol to the virtual switch as well, so support for that. And so what this enables, you can see in this picture over here, is a huge consolidation. You can actually put many, many virtual PLCs now on a single host, and you can enable large amounts of throughput now because of the fact that these two features are part of the virtual switch itself. And so it's a huge amount of hardware consolidation and a big win for the customer, and actually enables features they didn't even have before, in the sense that parallel redundancy protocol and industrial Ethernet is typically a 1 gig throughput on commercially available switches today. But in this model, through the virtual switch, the throughput can be much, much higher because we're building it into the virtual switch itself. And so the other side of it is this bit. And this is quite significant in the sense that to make any changes with these hardware appliances on the manufacturing floor, people actually have to go out to sort of physically connect and disconnect into those networks. And what bringing it into software, virtualizing this actually enables is that they can do this all automatically. They can automatically connect a VPLC to a VLAN just with software configuration now, right? They can disconnect it, connect it, whatever it is. And so it's an impressive amount of agility that this is enabling. And then finally, what good presentation could there be without something about AI, of course, that you guys have all heard here. And what I want to talk about is, so Project Keswick, as a good example of this, is a technology we incubated in the office of the CTO, and now we're commercializing through our VMware Edge Cloud orchestration product. In a similar way, we have a whole bunch of things that we're incubating in the office of the CTO and elsewhere within VMware as well around AI to sort of enable the same kind of thing. One big project is native support for Ray.io. So this is a framework that enables AI workloads to run efficiently on cloud environments. And we're looking to add native support for VCF, but then get to ECS as well, Edge Compute Stack as well. So at VMware, we always start with the data center and then get to the edge. And so this is kind of similar in that way. But that's one of the big projects that we're working on to enable AI workloads to run efficiently, enable the AI revolution. Another project is around resource optimization, automatically recognizing hardware acceleration like GPUs and things like that on the box, and how to optimally use those to run AI workloads, but also potentially even burst capacity to remote nodes as well, and run the AI workloads on hardware acceleration or resources that exist remotely as well. And then finally, this concept of federated learning, where the idea is rather than centralizing all the data and doing training in a central location like a data center, which is actually quite expensive, you see that with OpenAI and ChatGPT in terms of the cost of doing that, there's a model called federated learning where you train locally and all you send up is the model that's trained locally. And what you do centrally is you combine all those individual local models together to come up with a global model that's pushed back down to the edge locations. It's a lot more efficient. It's obviously going to be somewhat lossy. It's not as good as training centrally, but it's much more efficient from a cost standpoint, from a bandwidth standpoint, and so on. And that's another aspect of something that we're working on within VMware to this. So those are kind of the main things that I wanted to cover here. I'll hand it back to Saadat to just cover some of the pricing improvements that we've made. But thank you very much.
All right, thank you. Thank you very much. There was a lot of truth in that, I have to admit. So let me very briefly touch upon pricing. So as you were building this product, right, and we started taking this to market, going to customers, customers loved the fact that we were focusing on the edge and addressing the specific edge scenarios. But one question kept coming up again and again. I don't have one data center. I actually have 5,000 sites. So who is going to pay for all this? So we quickly realized that that was an issue. And what we did was that we went back to the drawing board and we said, OK, let's look at pricing that makes sense for our customers at the edge. So we have redone the pricing. We have come up with a no minimum based pricing. There's a limitation in terms of cores. So there were some features that we felt were not really required at the edge, so we removed those from the product. And we focused in on the features that are required. You also have pricing that we've done, T-shirt pricing, to very quickly make it easy for people to figure out how much it will cost. And then this is optimized for deploying at many, many different sites. So for those of you who are interested, we'd love to have a discussion, talk about what your scenarios are. Don't be frightened by the number of sites that you have to deal with. We have looked at that from a financial perspective and have a model in place which we can use to address it. There are other sessions, although I know that this was the best one out of all of them. But I'm told that I need to tell you that there are other sessions should you still have a need. So these are the ones, and yeah, they look awesome, although not as awesome as the one that you're in right now. So, and so let me leave you with this message, right? So if one thing that we want you to think about, what VMware is doing is we're removing the friction from deploying outcomes at the edge. And the reason we're doing that is that so you can focus on running your business at the edge rather than worrying about the technology and how you're going to make it work. That's what we're trying to do, and we're looking forward to partnering with all of you in that journey. Please do take the survey, and thank you so much for being here with us.